In this video, we're going to use mechanical switches to demonstrate a logic AND gate. AND gate circuitry has at least two inputs. There could be more. Usually there's two, so the truth table shows two usually, and one output. And what we're mostly interested in is what the output is doing. We control the inputs to set the output. So in this case, 0 is going to mean off, and 1 is going to be on. Our inputs are going to be switches. So 0 is an off switch, and then 1 is an on switch. That will control the output, which will be an LED. 0 means an off LED, and 1 means an on LED. As you can see here for the AND gate, for the LED to be on, both of these switches have to be on. Here is the schematic diagram. If there's only two inputs, if there's more, it'll probably say A, B, C, and so on. But in any case, the output may have X, and Y is another common one. So the outputs and the inputs are not universally labeled, but usually I see Y on the integrated circuit. So that's an integrated circuit. I'm reusing a diagram from an earlier video. So now, this is the schematic for the physical version that we'll look at later. As you can see, we have two open switches, so there's no way for current to flow through the circuitry there. And so with both of these switches off, the output will be off. If we press one of the switches, we still have an open switch. There is no current path. So even though we have one switch that is on, the output is still off. Same thing if we press the other switch instead. Now we have one switch on, the other switch off, the output is still off. Whereas if we press both of these switches, they're normally open switches, by the way. That's all I have for push button switches. That means they're normally off until you press the button. But if both of them are on, then the output will be on, and in this case the LED will be on, it will be lit. So now we'll wire up the circuit on the breadboard here. I have the power supply set to 5 volts and a maximum of 20 milliamps of current to make sure no more than 20 milliamps of current goes through the LED. Blow it out. The output is off right now. It's a good idea to build circuits while the power supply is off. But in any case, also, if we limit current and we short circuit this, it will turn it off right away. So that's a good power supply safety option, is when it turns off, when it short circuits. So to begin with, we'll come to the first switch. Pretty straightforward. Push button switch, and it's off unless you push the button. You have to insert it into the breadboard the right way though. And so these top two pins are always connected. The bottom two pins are always connected. Luckily, I should call them terminals. Luckily, they fit in the board nicely when you have it the right way when it comes to this gap. Whereas if you try to put it the wrong way on the gap, the pins are too close together to fit into the board. I'll zoom in a little bit. So you connect it that way, but in any case, you always want to make sure that you plug these in where the top is separated from bottom until you push the button. And the process is the same for the second switch, but we have to connect them together. So the first switch we connected to the positive side of the power supply up there. Second switch, we're going to come down here. Another thing is I usually put the middle of the switches, there's no terminal there, where the gap is there on the breadboard for a couple reasons. One, so it's easy to tell where the middle is and where the top and the bottom is. And also because these terminals are a little bit bigger than the wires of other components, so it kind of stretches out the holes, so it helps keep track of where these wired terminals might not fit in very well. So now we have our two switches in place. We'll take a 200 ohm resistor, go from the bottom of this switch to one row away from that jumper right there, and the leads are bent kind of at an angle. These are cheap resistors. Their leads are not as thick. They kind of bend easier, but I got a lot of values for not a whole lot of money, so it was kind of worth it. So in any case, long lead, the anode goes to the resistor there. Short lead, the cathode goes to ground. Just your basic LED protected by a resistor circuit. And we can test it out. So first, of course, I got to turn the output on. That's with the power button right there for this particular unit. Output's on. We press one switch, LED stays off. Press the other, stays off. So of course, if we don't press either, that's the other option, the LED is off. But we press them both, we turn them both on, the LED turns on. So again, that's a 220 ohm resistor. The LED is dropping a little bit of the voltage there, but otherwise about 3.5 volts or so. It's going across the 220 ohm resistor, and it is setting the current. So current is limited enough to protect the LED and the resistor. So that's what an AND gate is. Again, I use integrated circuits for AND gates in most of my videos, but where I will use them, but you can make them with a switch, and the switch one I think is easier to visualize what's going on.